All right. Good afternoon. Good afternoon. You're welcome to our tutorials on pharmaceutical calculation. Tutorials with from to the school board. Today we'll take a look at concentration. We have some questions on the board we'll solve. Question number 1 says 1 gram of active ingredient powder is mixed with 99 grams of white petrolatum. The final concentration is dash. Remember when we define concentration, we said that concentration has to do with what? Ratio of a particular ingredient, or ratio of the amount of a particular what? Ingredient to the amount of the entire what? Product. So the ingredient here is not mentioned. They didn't mention an ingredient. If the ingredient, let's say, assume the ingredient, as you see in the question, is 1 gram, then, and they define the total product, the total weight of amount of the product is 100 grams. That means concentration of that product, the concentration of the ingredient in that product is what? 1 gram over what? Over what? Over 100 what? Gram. But it depends on the concentration you are looking at. If you want to leave it as an amount concentration, that is what it is. But if you want to leave it as a percentage concentration, then you start multiplying by what? 100%. Or simply say, if 1 gram is in 100 gram, how many gram will be in 1 gram will now be in so amount. So that's basically what concentration is all about in terms of definition and mathematical what? Representation. So without wasting time, with this thing I said, now let's look at this question. The question says 1 gram of an active ingredient powder is mixed with 99 grams of white petrolatum. The final concentration is what? Now, I want you to remember something. That the products, entire products consist of active ingredient and other what? Ingredient. So this white petrolatum is just one of the ingredients, basically the base of this what? Preparation. So if you add 1 gram of the ingredient powder inside to 1 gram of 99 gram of what? White petrolatum, what it means is that the weight of the entire product will now be what? 100 grams. So you now have 1 gram of the active ingredient inside 100 grams of the what? Product. Is it clear now? So if you now want to find the concentration of this product, simply say 1 gram over what? Over what? In bracket, 99 from where? 99 from white petrolatum, right? 99 plus 1 gram over what? 99 grams from white petrolatum plus 1 gram of the what? Yes. So everything give us what? 1 gram over what? 100 grams. But it's always advisable to move this active ingredient, move it to be in milligram. If you're looking for concentration, if you're looking for, since both the active ingredient and the entire product are in the same.
Explain this 1 gram in that 99 gram.
I gave it a definition now. I said that concentration of a particular ingredient in a particular product is simply what? The amount of ingredient in question over the amount of the entire what? Product. And I also said that the product consists of both the active ingredients and the base and other ingredient excipients. Now, but if you look at the question now, the only excipient there is what? Is what? Gram of what? White. That's the only excipient there. While the active ingredient is 1 gram. So if you want to know the total amount of the product, is what? 1 gram, which is the amount of active ingredients, plus 99 gram, which is what? White petrolatum. That will give you what? 100 gram. So the amount now, the concentration now is now the amount of the active ingredients over the amount of the entire what? Products. But if you watch, these two are in the same, they have the same consistency. Is weight. Because it's weight, to avoid cancelling this into total, you can change this one to what? Milligram. So if you change this one to milligram, it becomes what? 1,000 what? Milligram over what? 100 what? Gram. This will cancel this. We have what? 10 milligram per what? Per gram. This is the amount concentration. Okay? This one is the what? Amount concentration. At this junction, from here now, you can move it to what? Percent what? Concentration. You can move it to what? To what? They didn't specify the concentration you should leave it in. So any of them, if you leave it in any of them, it's okay. I'll mark it. Because there's no specific what? Concentration stated that you should leave it in. So this one is the amount concentration. This one now, if you want to move it to percentage concentration, it's simply 1 gram over what? Times what? 100. Which is what? 1% what? Weight in what? Weight in weight. 1% what? Weight in weight. I follow you. Weight in weight. Now, if you want to move it to ratio strength, it becomes what? This 1 gram over 100 gram. This gram will cancel what? This gram. You have now 1 in what? 1 in 100 what? Weight in weight. So any of them is not bad. Any of them you leave it at is not bad. Why I move this to this is that it will cancel. If gram is a gram, cancel gram. It will not make more sense. It will not make sense, and you may look as if it don't have a unit, but it's actually an amount concentration.
This 10 milligram. We just do it like that. So the answer is I want to say 1 gram or 100 gram.
I don't answer your question.
The answer we got from the is it 1 gram over 100?
See the answer here. Any of these? So what else are you?
The answer we finally got. Is it this one or the other one?
This one. So any of the answers you leave it at, we will mark because there's no specific concentration you are told to leave it in. Is it clear? Okay, let's look at the next question. It says 6 grams of azelaic acid is added to 24 grams of cream base to produce azelaic cream. The concentration of this product is this and this. The two of them. This one and the previous one has the same. They are the same thing. It's just that the amount and the ingredients, they named the active ingredient here. Now the active ingredient now is azelaic acid, but the product produced is what? Azelaic what? Cream. So that means if the product produced is azelaic cream, you know that this is a solid dosage form. So if you want to know the weight of the azelaic cream produced, the weight is simply what? The weight of the what? The weight of the product. Is equal to what? Weight of what? Azelaic acid. Plus what? Weight of the what? As a what? Azelaic what? Cream. Simple. But concentration is basically what? Weight or the amount. The amount in here now is what? Weight. Weight of the what? Let's use amount because amount is more general. But when it comes to this question, it's weight. So, sometimes it may not be exactly weight, it may be more depending. But since we are, let's just say amount, okay? Amount of what? As the logic what? Over what? Amount of what? Over what? As well as what? Cream. So this means that the concentration here now is what? The amount of as azelaic acid is what? 6 grams over the amount of the weight of the amount of the product that is azelaic cream is what? Sorry, this is not azelaic cream. This should be, sorry, I made a mistake. This should be weight of the base. Sorry, cream base. Okay, the cream base. Sorry, I made a mistake. That should be the amount of the product, and the product we are talking about here is what? Azelaic what? Cream. So the amount of the weight of the azelaic cream is the weight of the. This is the active ingredient, which is what? Azelaic acid. Then plus the weight of the what? Cream base. The cream what? Base. So two of them now combined will give us the what? The weight of the what? Azelaic cream. But concentration is what actually? The amount of the weight of the what? The azelaic acid, which is active ingredient, over the amount of the total the product formed. So this is now what? 6 grams. What is the weight of the product formed now?
24 grams.
Products.
Sorry, the product is 6 plus 24.
Good, because 24 grams is the base, 6 grams is the active ingredients. So when you combine them, mix them properly, blend them properly, the weight you will get, all things being equal. Yes. Is now what? Is now what? Good. 30 what? 30 what? Gram. So this is 6 grams in what? 30 what? Gram. If you break it down, you have something like this. 6 grams. This is 1 gram over what? 5 what? Gram. Now, if you like, you can leave it as 0. This is 0.2, right? 0.2 gram per gram. But in most cases, this numerator is always, since they have the same weight, the same consistency, solid. Most of the time, this is converted to what? A lesser what? Unit, like milligram, so that you now have some, because you know that is a concentration. Milligram cannot cancel that milligram. So if you do that way, now you have something like this: 1,000 watts, 1,000 watts over what? 5 grams. So this will give you what? 200 milligram per watt. This will give you what? 200 watts milligram per watt per gram. They didn't specify again the type of what? Concentration they are looking for. They didn't specify. So if you can also find this as what? Percentage what? Concentration by simply doing 6 grams over 30 times what? 100. We have what? Gram. This cancel this. This cancel this. We have what? 5. So we have 20 what? Percent weight in what? Weight. As percentage what? Concentration. Now if you want, you can trace it as what? Ratio concentration. Raise it, divide it until this one becomes 1. Until the numerator becomes 1. And if you do it, you have 1 gram over what? 5 grams. Gram will do what? Cancel gram. So we have 1 in what? 5 weight in what? Weight. So this is the 3 concentration it can be. Anyone you solve, anyone you decide to give me, I'll mark it, because the question didn't, unless I specify in your question that you give solving in a particular what? Concentration. That's why you now follow a particular one. If not, anyone is, question like this, anyone is okay. Also, unless maybe you are in an OBJ examination and the OBJ had the concentration there of course it will be a specific one. Then you cannot solve in that line. Yeah.
So what of if you know the answer that as in this 30 gram of protein, the answer would be like 30 weight in weight. Is the answer okay?
30 with power.
You will not put that 6 gram.
No, it's wrong. That is not the concentration. It's not the concentration. If you break it down, you see that it's wrong. It's not the concentration. Okay, even if you leave it as 0.2 gram per gram, I'll mark it. But I just want to let you know what how they normally are. There's some book you see, they leave it at this point. But I prefer you to leave it at this point here. If you must use amount concentration, okay? Okay, well, okay, if you're done here, let's go to the next one. Okay, let's go to the next question. It says, higher tone contains 500 milligram of hydrocortisone powder with 9.5 gram of emollient what?
19.5.
What's that?
19.5 of emollient. What's 9? You said 9.
Okay, I said 9?
Yeah.
Okay. Okay. Higher tone contains 500 milligram of hydrocortisone powder with 19.5 gram of emollient base. The percentage strength of higher tone is dash. Now, higher tone is the product itself, okay? While the active ingredient inside the higher tone is what? 500 milligram of what? Hydrocortisone. And the base, the emollient base there is what? 19.5 gram. So they want us to find the what? Percentage strength. So from this now, what is the weight of the product now?
The weight of the product is 19.5 gram plus, if you convert 500 to gram, it will be 0.5 gram.
Good. You need to convert that for the 500 milligram to what? But they need to be in the same base. So they need to be in the same units. Once you come to percentage strength, everything they have to be, unless we have volume, weight in volume. But once it's weight in weight, volume in volume, they must be in the same units. Okay? But if it is weight in volume, the weight must be in gram and the volume must be in what? Ml, if it's weight in volume. But if it is weight in weight or volume in volume, two of them must have the same units. It doesn't matter whether it is in gram or milligram, but if the active ingredient is in milligram, the entire product should be in what? Milligram. So you must get the same units. So let's go. So if we convert this now to gram, if we like, we can also convert this to milligram. Hope you know.
Yes.
So if you convert this 500 milligram to gram, you have what? You have what? 0.5 what? Gram. Good. So that means percentage strength now. Percentage strength now is now equal to what? The weight of the what? Active ingredient, which is what? 0.5 gram. Over the weight of the product, which is what? 20. Because you add up now.
Yes, 20.
19.5 gram plus what? 0.5 gram, which is what? 0.5 gram over what? 20 gram. Then percentage now you multiply by what? 100. So gram will cancel gram. So 20 divided 100 is what?
It's
5. So 5 times 5%. 5% times 0.5 is what? 2.5% what? Weight in what? Weight. Please don't play. If you write this thing and without putting this in, you fail. Hope you know you failed it. Because that is confusing. So it's what? 2.5% what? Weight in weight. All right, write out the other questions. Let's see. We'll keep working on it. If they come, fine. If they don't come, then what's our target today? How many questions did they target, Gideon?
12.
Okay, our target today is 12 questions.
No, not 12. 24%.
And we are saying number 3. That means we will not meet our target today. Meet how? It's only after 4 years. You say that you meet the target. Anyway, it's okay. Right at the next question. Let's see how far you can go. Okay, let's look at the next question. The question says, the amount of silver nitrate needed to prepare 1 fluid ounce of a 35% silver nitrate solution is, you know that the meaning of 35%. This is a solution of, there's a silver nitrate in solution. That means weight in what? Volume, right? True of us. Because on a normal, silver nitrate is a solid. So if it dissolves, solution, so it's solid in one, liquid, so weight in what? Volume. So with that at the back of our mind, we now break down this 35%. So what does 35% mean? 35 units
35 grams
in good, in 100 what? Mil. That's the meaning. So 35% weight in what? Volume is what? 35 what? Gram. Okay? Of silver what? Nitrate. In what? 100 mil what? Solution. So the question now says, what is the amount of silver nitrate required to prepare 1 fluid ounce? So if there are 35, if you have 35 grams of silver nitrate in 100 mil, how many will be in 1 fluid ounce? So let's convert 1 fluid ounce to what? Mil. 1 fluid ounce is equal to what? 30 what? Mil. So we replace that 1 fluid ounce with what? 30 mil. So how many S of what? Silver nitrate we found in what? 30 mil. So let's find this X. Is it clear? So X is now equal to what? 35 grams times what? 30 mil over what? 100 what? Mil. 100 mil. Sorry. 0 cancel 0. We have this. So 5 can go here, right? We have 2. 5 can go here. We have what? 7, right? 7 times 3 is 21. 21 divided by 2 is what? 10.5. So we have what? 10.5 what? Of 10.5 what? Mil cancel mil. Gram. So if you need 10 point, if you dissolve 10.5 gram is what you need to produce it at 5% weight in volume of silver nitrate in the entire solution will be 30 ml. So you need 10.5 gram of what? Silver nitrate. Is it clear? Now let's look at the next question. Okay, put it down. All right, let's look at the next question. The question says, dash milligrams of drug are needed to make 5 ml of an 8% what? Solution. Dash milligrams of drug are needed to make 5 ml of an 8% solution. The first thing is to break down that 8%. Look at the type of drug it is. Is a solution, right? And they already mentioned milligram of drug. So this is a case of weight in what? Volume, right? Do you agree with him? So you guys are good with 7984.
So yeah, so me and I saw
Okay, you want to solve it yourself first.
Okay, I'll tell you how George.
Also, we just solve 190.
Okay, Messi there was that one. Messi the jacket.
Will you solve it.
8 gram is to 100 ml.
Okay,
How
okay.
many ml? 5 ml.
Is it what do you call? Because even at 8% means 8 gram in 100 ml. So how many gram will be in 5 ml? I think that's what 78 is all about. Then 8% means 8 gram in 100 ml. So if there are 8 gram in 100 ml, how many gram will be in 5 ml? Sorry, milligram. But see, you know that we have 8 gram in 100 ml, but we are told to find it in what? Milligram. So you find how many gram in 5 ml first. You want to say how many gram that will be in 5 ml. You now convert it to what? Milligram. Is it clear? No, to milligram. The question is that's the question is in milligram. We are told to find how many milligram. No, 8 gram in 100 ml. Then how many gram will be in 5 ml? You want to say how many gram that will be in 5 ml? You now convert it to what? Milligram. Is it clear? Eh?
So converting into milligram is the answer you got divided by 1,000.
No, times 1,000.
Okay, times 1,000.
You know that 1,000 milligram make 1 gram. So if you want to move from gram to milligram, you multiply by 1,000 because gram is greater than milligram times by 1,000 times. So before you move, if you want to move from gram to milligram, that means you multiply by 1,000. You multiply that whatever you got in gram by 1,000 before you can shift it to what? Milligram. But if you are moving from milligram to gram, you divide by what? 1,000. Then 79 is in mil. 3% is already what? 3 what?
3 grams.
There's an error in that question. The question said that milliliters of a drug are needed. Okay. It's a liquid. Thank you. Sorry. It's a liquid in what? Is volume by what? Volume. Sorry. It's not an error. So if you want to solve something, be careful because if you're not careful, you will misinterpret it. If you see 3%. So this 3% will now be 3% volume in what? Volume. Good. So this is simply what? 3 ml in 100 ml. So if you have 3 ml in what? 100 ml, then how many ml will be in what? 600 ml. You just 3 ml, 100 ml. How many will be so 3 ml times 600 over what? 100, which is 18 mil. 18 mil, right? It's 18 mil. Two of us, because we have 3 mil in 100 mil, dash x in 600 mil. So that 3 times 600 over 100. 100 divided by 600, we have 6. 6 times 3 mil is what? 18 mil. So it's 18 mil. It's simple. Anyway, as he said, it's simple. Number 90 says, express the concentration as a ratio strength of the solution prepared according to the directions given in the prescription below. Good. Potassium permanganate tablets, 0.2 gram, dispense what? 100. Senior, 2 tablets in 4 pints of water and use as what? Directed.
So 2 tablets in
4 pints of water. 4 pints of water and use as what? Directed. Now listen. This is how you prepare it. Okay? They're already giving you what 1 tablet contains. Two of us. One tablet, that product is a tablet of potassium permanganate. Inside that 1 tablet, we have 0.2 gram of potassium permanganate. So the active ingredient inside 1 tablet is what? 0.2 what? Potassium permanganate. But you are told to use what? Use what? 2 tablets. 2 what? Tablets. So if we use 2 tablets of it, that means you're using how many gram? 0.4 gram. Is it clear? Is it clear? So we have 0.4 gram of potassium permanganate over what? Over what? 4 pints. 4 what? Pints. Is it clear? But we are told to leave the answer as what? Ratio strength. Look up. Look up. Look up. Remember I told you whether it is ratio strength or percentage strength. Whenever you are working with weight in volume, the weight must be in what? Gram. And the volume must be in what? Mil. Is it clear? Now, the weight is already in gram. Let's convert these 4 pints to what? Mil. Is it clear? Let's convert these 4 pints to what? Mil. Now, we know that 1 pint contains 4 what? 4 what? 47 what? 473 what? Mil. Am I communicating? 1 pint contains what? 473 mil. 473 what? Mil. Now, if 1 pint contains 473, so 4 pints should be what? 4 times what? 473 mil, which is what? Huh? 1892 mil. Okay, so this is certain as saying 0. What? 4 gram over what? 18 what? 92 mil. But we are told to find it in what? Ratio strength. In ratio strength, the numerator must be what? 1. And the easiest way to make this numerator, look up, the easiest way to make this numerator to be 1. Remember what we did in equivalent fraction. Remember, the easiest way to make this thing to be 1 is to divide both the numerator and the denominator by what? By the denominator, which is what? 0.4. Simple. So if you divide here by 0.4, divided by 0.4, this will turn to 1. Alright, let's do it. This is what? 0.4 gram over what? Over what? 1892 mil over what? 0.4. The denominator is now 1 what? Gram. This one is now what? Divide is 1892 by 0. Divided by 0.4. what? 30. So this is now what? 4007 what? 30 what? Mil. So in ratio strength, this becomes what? 1 in what? 4730 what? Volume in volume. Sorry, you are correct. Weight in what? Volume. Potassium permanganate is a solid. So it's weight in what? Volume. Good, thank you for that. It's weight in what? Volume. It's simple now, right? He's laughing. But it's simple now. Isn't that? I get you. It's simple. Alright, if you are done, we'll get more questions so that let's see how far we can go. I mean, if you're able to, I just pray that we'll be able to finish our 24 questions. Then we call it a day. I'll put an idea as a man lock. Let's look at this question. The next question says, purified water contain not more than 10 ppm, that is parts per million, of total solid. Express this concentration as a percentage. Of course, you know the meaning of part per million. One parts per million. Parts per what? Million actually means, depending on the dosage and the consistency of the product you're talking about or the mixture. If it is liquid, solid in what? Liquid. The same thing holds here. The solid must be in what? Gram. and the liquid must be in what? Ml. So it must be in gram and ml. But if it is solid in solid, it doesn't matter, or liquid in liquid, it must not be. The most important thing is that two of them are weight. They must not be in gram. They can be in milligram, but the two of them must be in the same units. If let's assume it is solid in solid, if you want to choose in gram, they must be in gram. Even if they're not, you convert it before you start solving. But once it's solid in liquid, the solid must be in what? Gram, and liquid must be in what? Ml. Now look at this. When with respect to solid in liquid, 1 part per million actually means what? 1 gram in what? 100 what? Sorry, 1 gram in what? 1 million what? Ml. That's the meaning. Okay? 1 part per million with respect to solid weight in volume is 1 gram in what? 1 million ml. The same thing with 1 part per billion, 1 ppb. Billion means 1 gram in 1 billion what? Ml. That's the meaning. Now, but we are going to move this to what? Percent. How do we do it? You can do it either of this way. If there's 1 gram but sorry, what we are giving is what? 10. So this means 10 gram in what?
In X.
In what? No.
Okay, in
Yes. I defined part per million, but we are giving 10. So if you are giving 10, it means what? 10 gram of the solid in what? 1 million ml of the solution. Is it clear? Yes. So we have 10 gram in what? 1 million what? Ml. But we are going to move it, check it as what? Percent. When you hear percentage, it means in 100 ml. Two of us. So if we have 10 gram of the solid in 1 million ml, how many gram of the solid, we call it X, will be in what? 100 ml. So percent means in 100. So that means X is now what? 10 gram times what? 100 ml over what? 1 million. 1 million what? Ml. Ml will do what? Cancel ml. We have 30 here, right? So they'll take care of what? 30. So you have this will take care of 30. So we have what? 1,000, which is 0. What? 00 what? 1 what? 001 1 what? A gram, sorry. Gram, not percent. Gram, because we are looking for the gram. What is it called again? The what? No, it's not true. Wait. I'm coming. There's an error here. Let's look at this question again. The question says,
purified water contains
more than 10 parts per million of total solid. Express it as a concentration. Part per million means what? 10 gram in what? In 1 ml. Right? We got it. We are not wrong. We got it. Watch out. 10 gram in 1 million ml. So how many gram will be in what? 100 ml. We find the gram first. So we have 100 gram in what?
In 0.001
0.001 gram in what?
in 100 ml.
In 100 ml. So if you have 0.00 gram in what? 100 ml. What does it mean? Tell me now. Tell me what it implies. We got it correct, but tell me what it actually implies. We have 0.001 gram in 100 ml. What does it mean?
1,000 1 gram in 100
gram
of the solid is in 100 ml. Yeah, ml. So what is the percentage now?
The percentage is that's 0.001 gram. Sorry, 0.001. Wait. Times 100.
You don't understand what? What's the meaning of percent?
Percent means
So if something is 1%, what does it mean? If you are dealing with weight in volume and something is 1%, what does it mean?
1%. It means it's 1 in 100.
One what? 1 what?
1%
Is 1 what in 100? 6 in 100 mil. So if 1 gram in 100 mil is 1%, 0.001 gram in 100 mil is how many percent?
0.001%.
Is it not? If 1 1% weight in volume actually means
what you mean as in what does this thing?
yes,
Okay,
in percentage.
What it implies is 0.001% weight per volume.
Perfect. That's the meaning. That's the interpretation of this now. There are 0.001 gram in 100 mil. The meaning is what? 0.001% what? Weight in what? Volume. That's the meaning. So the percentage of this is simply what? 0.001% weight in what? Volume. Then if you don't want to go through this step, you can simply divide 10 gram over what? 1 million, right? Mil times what? 100%. This gram over mil will be turned to what? Weight in what? Volume. This gram per mil will change to what? Weight in volume. Then you cancel out. This will take care of 110 here, right? This 0 will take care of this. So 1 over is 0.001%. You have changed this gram over mil to weight in volume. So you now have 0.001% what? Weight in volume. You can do it this way, but do you know why I like? This is actually the meaning. This is the real meaning. Most people may be doing this without even knowing what they are doing. That's why I like breaking it down, so you understand where it came from. But because for the purpose of the exam, you can simply something like that. Because do you know where you know there's a place you go, you don't know where it's here. They may want to ask you. You will say, how? What do you mean by the real interpretation is what? 0.00. It's not ordinary percentage you use in your general mathematics. This is actually the interpretation, what it means. All right, if you are done, let's look at the next question. All right, this question says, how many grams of hydrocortisone should be used in preparing 120 suppositories, each weighing 2 grams and containing 1% hydrocortisone? Here, if you watch this thing now, both the hydrocortisone and the entire suppository are what? Solid. True of us? Now. So when you see 1%, what that 1% actually means is what? Remember that this letter say 1% weight in what? Weight. Okay, no. This actually means what? 1 gram of what? Hydrocortisone.
Yes.
1 gram of what? Hydrocort, right? In what? 100 what? Gram of what? Suppository. Is it clear? That's the meaning. Hope you know. Are you aware? Suppository, both the hydrocortisone.
100 grams supposed to be 100 ml.
So suppository, is it a liquid preparation?
It's 120, not 100.
You say that 100 should what?
Should be 100 ml, not
Mil. Mil is for volume now, for liquid.
You say that this 1%, is it not 1 gram is 200 ml?
1 gram in 100 gram.
How many grams of hydrocortisone used in preparing 12 suppositories?
Is it 12 or 120?
120 suppositories, each weighing 2 grams and containing 1% hydrocortisone.
Okay. So that 1%, what does it mean?
1 in 100 ml. 1 gram.
Mil. You don't talk of male. This is not a liquid preparation.
So how many grams?
Suppository is a solid preparation. It's not liquid. So it's weight in weight, not weight in liquid, not weight in volume. That's why I say that. That's why I wrote this in word as weight in weight. So what it actually means is that look up. It means there's 1 gram of hydrocortisone inside 100 gram of suppository. But the weight of suppository for one suppository is what? Forget about the number of suppository for now. We will still use it. But what is the weight of one suppository? 2 grams. So if this percentage means 1 gram of hydrocortisone in 100 grams of suppository, and the weight of one suppository is what? 2 grams. So how many hydrocortisone will be in what? 2 grams of suppository. Yeah, one suppository. How many will be inside 2 grams of what? Suppository. We find this S. Are we together? So that means X is now equal to what? 1 gram times what? 2 grams over what? 100 what? Gram. 1 gram cancel 1 gram. So let's go. 2 divided by 50 is what? 2 divided by 100 is what? 50. So 1 gram divided by 50, basically 1 divided by 5 is just 0.2. So that means 1 divided by 50 is what? 0.0 what? 2. So this is what? 0.0 what? 2 gram. So that means one suppository that weighs 2 grams. Inside that suppository, one suppository, you have 0.02 gram of what? Of what? Hydrocortisone. But we are asked for 120 suppository. This 0.02 gram is the amount of hydrocortisone inside one suppository. 3 of us. Now, how many will be inside 120 suppository? Perfect. 0.02 gram times 120. Because number of suppository is what? 120. So you multiply this 0.02 gram. 0.02 gram times what? 120. Which is what? Which is what? This will eat 10 here. So we have 0.2 times 10 times 20. So this should be 2.4, if I'm not mistaken. It's 2.4, right? So total amount, the total weight of hydrocortisone that will be inside 120 suppository is what? 2.4 gram. So we have 2.4 gram of what? Hydrocortisone inside the 120 what? Suppository. Okay, Zoku. Yeah, I forgot that now. Okay, people are not yet back here. So this thing we still talk about Monday. Only work. Okay. Even on Monday again. Monday. On Wednesday up here. You have the right up here. Monday, Wednesday, Tuesday, and Wednesday. It will be 7 to 9. But will you still go back, or you stay next day? Can you come on? It will be 7 to 9. Okay. Or maybe I normally dismiss here by 6 p.m. So if people can, my tutorial on the early by sometimes it will lead to 6:30. Target the other period. So that quite late in the night, depending on your program. I'm on how you want to do it. Up to 7 to 9, guys. Just targets. Tutorial. Just hang around. Most of I would do our own. Because the tutorial ends by 6 p.m. So target at 6 p.m. So 6 p.m. You can be solving some things on your own. Maybe you pick those quick questions and be looking at them so that it will be easier for us. If you look at them, there's I will see what people have done. Where and where to say 1 or 2 things so we can finish on time. I'm going to I won't know as well. Go to anywhere place you know. Okay, let's look at this question. The next question says, the amount of albuterol sulfate needed to compound 120 unit dose vials in bracket 3 ml of 0.042% albuterol for nebulization is dash. Did you see a nebulizer at Cocoa? You see that the liquid, right? You saw it, right? You now appreciate what you are doing. It's in liquid form, true of us. So that means it should be what? Weight in what? Volume, right? It should weight in what? Volume. So that actually means that this 0.042% is actually means what? 0.042%. Weight in what? Volume. Actually means what? 0.042 gram of what? Albuterol in what? 100 ml what? Solution, right? Right? Good. It's a solution. It's not true. It's a what? Solution. It's a solution for the nebulizer, right? Now, even though so call it nebus anyway, nebus. I think let me use nebus so that it will enter well. Okay. Let me use one. Even though let me just use nebus, it will enter well. Now look at this thing now. Yeah, 0.042 gram of the drug is which is albuterol in 100 ml of the boost. Now look at the vial now. If each vial is what? 120 units dose vials. 120 unit dose vials what? 3 ml. What do you understand by that thing? You wrote there. 120 unit dose.
120 unit of the albuterol sulfate is in 3 ml.
120 units dose vials. Is it the vial that is 3 ml? I want the vial. That means one vial is what? 1 vial is what? 3 ml, right? That's the meaning, right? Now, what do you understand by that 120 dose?
120 dose is
Is what? 120 unit dose vials. 120 unit dose vials. 3 ml. Give me the original question. Let me see. So a vial is what? A vial is what? 3 ml, right? Now, what can you make out of that 120 unit? Is it saying that a unit is from that 3 ml they can give 120 units? Is it possible to have 120 units in that 3 ml? It's small now. How? Did you bother to check how they use that nebulizer? Now the point we see where I'm going to now. This 120 unit dose. I want to see what you understand or what you can make out of it. Now, is it saying that that 120 that inside that 3 ml, from there you can give up to 120 dose? Is it possible?
each vial is 3 ml.
Each vial.
So in that 3 ml, you can take out up to 120 units in this 3 ml. That's what it means. So this
is that it mean? 120 unit dose.
The dose.
Vials. 3 ml. So if there is a case now, so what will now be the answer?
0.04%. gram in 100 ml.
Uh-huh.
Okay. Then we will find for this 3 ml.
For this,
Not the 120.
if I for the so how many will be how many gram will be in 3 ml?
3 ml times 100 divided by 0.
Oh yeah, do it.
Which is 3.
No, it's not 3 ml times it's 0.042 times 3 ml.
Yes.
Divided by 100. So what will it give you? Excuse me, I'm coming. What did you get?
0.0126.
0. What? 01.
0.13.
0.02 what? 126. Is it clear, Zachariah?
But sir, please, even actually amount of material sulfate needed to compound 120.
No, see what happened. That thing is, see what happened. You actually, the vial, one vial, is 3 ml. Inside that one vial, unit is very, very small. So is that one vial that has 3 ml that can give up to 120 unit doses? Am I communicating? So the answer is actually that thing. That 3 ml is telling you that just the one that vial that hold this 120 unit vote is 3 ml. So that's what. If you now want to find out how many gram a unit will now contain, you divide this thing by 120. Am I communicating? If this thing now is equal to 120 units, what if 0.0126 gram is equal to 1 unit? Is equal to 120 units. Therefore, 1 unit will now be what? You divide this 0.00126 by 120. You now know how many grams that will be obtained in one unit. And in fact, it will even be in range of micrograms. Yes. Now on a normal, it's in range of microgram. On a normal, if you check all those things, where you check it, is there most of these inhalers, they are in micrograms, true of us. So that just this itself is big itself, because if 120 a unit should be 0.000, is in the range of micrograms. You've seen it, right? Good. So the answer is what? 0.0126 gram. It's okay, or better see. They didn't talk about. If you like, you can even change it to milligrams or microgram. What do you mean? But don't approximate it, leave it.
Change it to milligrams.
If you change this to milligrams, just more. Here, can multiply here by 1,000 now. Yes. If you want to change it to microgram, multiply by 1 million. You move it to microgram. Because here now 1, 2, 3, 4, 5. Okay, I get 120 something microgram. Or 1,200 something microgram. Okay, 1, 2, 3, 4, 5, 6. 1,260 microgram. If you put it a microgram, but if you take it to milligram, it will give you 1, 2, 3, 1.26 milligram. Is it clear? All right. So, yes. Okay. We are good with this one, right? All right, the next one says 20 ml of butyl stearate is mixed with alcohol to produce a 400 ml mixture. The final strength of the product is dash. 20 ml of butyl stearate is mixed with what? It's mixed with what? Alcohol to produce a 400 ml mixture. the final strength is what? Of the product is what? Of course, this is our normal thing now. If you want to check the active, what is the active ingredient there? Mixed with what? Mixed with what? Alcohol. The final strength of the product is what? So simply 20 ml over 420. It's not. It's not. If you now want to, they didn't talk about, you can leave it in, what is it called? If you do it now, you have 20 ml over 420. Okay, let me do it.
Sorry, okay.
I've added everything down. Is it clear? The product is what? 20 ml alcohol, 20 ml butyl stearate, 400 ml what? Alcohol. Is it clear? Is it clear? So you have 20 ml over what? 400 ml plus what? 20 ml, which is what? 20 ml over what? 420 what? Ml. If you divide this, we have what? What? Just divide this first. What's the answer? Divide this first so we don't waste our time. What's the answer? 0. What?
0.47.
47 what?
6.
476 what?
1.
Mil per what? Mil. Okay? Mil per what? Mil. If you like, because of what I told you, you can leave this one in what? Liter, okay? Okay? You can leave this one in what? And how do you think we can leave this one in liter? How do you think we can leave this one in liter? If you want to leave this one in liter, how will you do it? You want to leave the denominator in liter. How do you do it? You do it by what? So you now say 20 ml over what? 420 ml over what? What? 20 ml over what? Divide this. Don't worry, let me do it as fraction. Here has become liter already, right? So you have 20 ml over what? 1 times what? 1,000 over what? 2 of us, liter.
No, 4.2 liter.
No, I'm not. I did 420 over 1,000. I'm not punching calculator. I'm just doing that fraction. I'll tell you when to punch calculator. So we have 0 will cancel what? 0, right? So we have, so just simply do 2,000 divided by what? 42. No. 2,000 divided by 42 will not give you 0 point. Should give you 40 something.
47.619.
47 point what?
62.
60 what? 62 what? Mil per what? Liter. Is it clear now? That's what we have. That is, if you want to leave it as amount what? As amount what? Concentration. This is as a what? Amount concentration. Then if you want to leave it as percent concentration, see what you have. You have 20 ml over what? 420. Just multiply by 100 straight and go your way. Mil will cancel mil, okay? 20 times 100 is what? 2,000 divided by 420 is what? 47.62% what? Volume in what? Volume. Is it clear? Is it clear? Good. This is as what? Percentage strength. This is as what? Amount what? Strength. Okay? Now, if you want to leave it as ratio strength, what will we now do? Remember our target in ratio strength. We already have what? 20 mil over what? 420 mil. Our target is that here should be what? 1. So we divide both the numerator and denominator by what? 20. So we have 20 over what? 20 mil over what? 20. Divided by what? 420 mil over what? 20. This one will give you 1. 420 divided by 20 is what? 21, right? 1 over what? 21. So it will give us what? 1 in what? 21 what? Volume in what? Volume. So anyone you are comfortable with, I'll score you. Is it clear? Because I didn't specify
The concentration.
Yes. Anyone? That means before you answer the question, please read the question well. Read the question, read the instruction on what you are expected to do, so you don't make mistakes.
Divided by 2.
That means you have what?
As your answer.
You have 0.04761 mil per minute. I'll mark it, no problem.
No, they will not give you this 0 point. They'll just leave it like this. Will you mark it?
No, it's wrong. Completely, you don't leave the answers. See, when the number you are this is careful. When the number you are dealing with is a denominator number in FARMACEUTICAL, please avoid common fractions. Okay, bring it down to what? Decimal fraction. Okay, unless the question itself is a common fraction. If not, bring it down to what? Decimal what? Fraction. I think as you said, since you're coming from maybe we can stop here so you can go. How do you mean you could come on time now? At least would have used 2 hours at least by now. If you came since 2 and we stay till now, that means we would have covered. But no problem. I don't know how the road is, so I don't know. Obodo is not that okay now. So I don't know if okay. By the time if you enter on that topic now, by the time we now finish, maybe we finish around after 7. That means you will not go back again. So what I say? Should we stop here? Huh? The time I dedicated for this tutorial is at least 2 to. My plan is 2 to 6 p.m. If I handle it from 2 to 4, then the other people 4 to 6. That's my how I program today's Sunday's tutorials. But since others did not come, so that's why we are doing. So if you say we'll stop here, then we'll stop here. What happened there? Just it's okay. Where is it? It says, what is percentage strength, weight in weight of a solution made by dissolving 62.5 gram of potassium chloride in 187.5 ml of water? What is the what? Percentage what? Strength, weight in what? Weight of a solution. Okay. Okay. One ml of water is what? 1 ml of water is equal to what? In gram. Water, not solution. Water itself is 1 gram. Water itself is 1 gram. It's not true. So move this 1 gram of one. That means this becomes what? 185 gram of water. It's not. If one ml of water is 1 gram of water, so 187.5 ml of water is 187.5 gram of what? Water. It's not. Now, you now add it to this potassium chloride, which is in gram. Add 187.5 gram to 62.5 gram. Whatever weight it gives you is the weight of the product, the weight of the solution formed. Then if you don't want to get the percentage strength in weight, you will not divide 62.5 gram by that total weight you got and multiply by 100 and you get your answer. Do you understand it? Then above. Then so I can solve it well. Maybe after that we can go. So just write on board so I can solve it. After that we can go. Okay. The question says, what is the percentage strength weight? If you watch now, look at the question. What is the percentage strength weight in weight of a solution made by dissolving your 6 because it's 2.5. Which one? Dissolving 62.5 gram potassium what? Chloride in 187.5 ml of what? Water. Now watch. Remember, by the time we go to specific gravity, density, you understand. Well, I'll refresh our memory on this one. You borrow some things from specific gravity and density here. For water, it has been concluded that 1 gram is what? 1 ml. For water, okay? Now 1 gram is equal to what? 1 ml. Now, if 1 gram of 1 gram of water is what? 1 ml. That means 187.5 ml of water is equal to what? 187.5 what? Gram of water. True or false? True or false? Remember that the solution was formed by dissolving potassium chloride in water. So if you dissolve potassium chloride in water, that means you are adding 6.25 gram of potassium in 1,875 gram of water. True or false? True or false? Therefore, by adding 62.5 gram of what? Potassium chloride into what? 187.5 gram of what? Water. The weight of the solution is equal to what? 62.5 gram plus what? 1,875 gram, which is what? 62.5 plus 1,875 is what? That is 2 what? Is it or 250? Which one? 250 gram, right? So 250 what? Gram. So the solution has weight of what? 250 what? Gram. So if the solution has a weight of 250 gram, this is the product produced. Hope you know. That's the weight of the what? The product produced. But the weight of the active ingredient there is what? Potassium chloride, which is what? Weight of potassium chloride added is what? Therefore, percentage strength, weight in weight. Percentage strength, weight in weight is now equal to what? 62 point what? Over what? 250 what? Gram times what? 100%. You are good to go. What's the answer? 62.5 divided by 250 times 100. Huh?
25 weight.
So the answer is what? 25% what? Weight in what? Weight. Yeah? Is that what?
I was receiving some fruit. Thank you.
All right, see you tomorrow then. All right, God bless you.